next speaker is Markus Kitsinger with the iRODS Consortium, and his talk is entitled iRODS Build and Packaging 2024 Update.
Howdy, I'm Marcus. I'm the build engineer for the iRODS team. My main focus is on the build system and packaging, and that's what we're going to talk about today. So here's a quick overview of the talk. We've got some versioning changes to go over, the recap of our current plans for the build system and packaging, our current progress on those plans. We're going to talk about externals, some other things that have happened, some notable yaks in need of shaving, and some other considerations. So first up, the next major release of iRODS is 5.0. There's not going to be a 4.4 series. Also, following the 4.3 series, major releases of iRODS will be version 5.0, 6.0, 7.0, etc. Currently, our major releases are version 4.1, 4.2, 4.3, etc. Minor releases will be versioned 5.1, 5.2, 5.3, etc. Whereas currently our minor releases are version 4.3.1, 4.3.2, 4.3.3, etc. We're also adopting GNOME-style development versioning. So between releases, the code in our Git repositories will have development version numbers. And we've already started doing this in our main branch. So 4.90 and 4.91 are development versions of 5.0. And this will apply to stable branches as well. So 5.1.92, 5.1.96 would be development versions of 5.2. Custom CMake package version file that takes into account development version numbers and versioning change for 5.0. So when you call find package in CMake to build against iRODS and you pass in a version number, CMake will look at this package version file to determine if the version of iRODS on the system is compatible with the build. So a quick recap of our plans. This is pretty much a copy of a slide from my 2022 talk. We want to transition to the standard tools for packaging. That's dpackage build package for deb packages and RPM build for RPM packages. Git build package will be used to maintain Debian packages the way Debian does on their Salsa GitLab instance. We may also use Git build package for maintaining our RPM packages as well. It does seem to have RPM support, but it's not used very widely. So there might be a reason for that. We still have to investigate. We don't want to provide externals packages when a distro provided package will do. We want to provide source packages in our package repositories. We want to follow established patterns for setting up service accounts. We want to install everything in the normal locations, and we want to provide default systemd unit files. We also want to build against libstandard C++ instead of libc++, and we want to remove all externals related plumbing from our build system so that we are not reliant on our externals packaging implementation details. And here's our current progress on those plans. We decided to transition to libstandard C++ before moving away from FPM and CPAC. This will allow us to reduce the number of externals packages we provide, which will facilitate the transition to standardized packaging for externals. This also meant putting a lot more effort into the current external system than I really wanted to, and I'll get into that in a bit. iRODS 5.0 will be built against libstandard C++. And a quick clarification on that. This is a change of the C++ standard library we are using. This is not a change of compiler. We are still using Clang, and we are not planning to visit switching to GCC until after our packaging situation has been sorted out. Continuing, some externals are now used via find package. And the build system for MungeFS, which is a tool that we use in our testing, is now normal and boring. It no longer has any externals plumbing at all. Speaking of externals, in order to build iRODS against libstandard C++, externals also need to build against libstandard C++. But iRODS 4.3 is still built against libc++, so we have to support both until 4.3 is EOL. Some packages now have two variants, one for lib standard C++ and one for lib C++. We've also added a package and removed a bunch. We added JWT-CPP for the HTTP API provider client. We removed Elastic Client and CPR because there's no single version compatible with all versions of curl we must support. We removed JSON because it's been replaced by nlom and JSON. We removed Pistache because the one project that was using it has been sunset. We removed libs3 because we removed libs3 because the relevant code was absorbed into the S3 resource plugin. We removed AWS SDK CPP because it was originally added for the S3 resource plugin but was never used. We're looking at removing libarchive, Redis, and 0MQ4-1 because once we drop support for EL7, the distro provided packages should be sufficient. And we're also looking at removing nlom and JSON because the distro provided packages might already be sufficient. This brings our current tally of externals packages to 17, with 7 of those having variants for libc++ and 1 being libc++ itself. So here's the more work that I mentioned before. Each package now declares dependencies per distribution, per version. This was always a spot where our external system was lacking, but the need became even greater with the transition to libstandard C++. We have a new source patch system. The external system can now apply patches to source code before it is built. And this was initially added for Ubuntu 24.04 support because our Clang package required changes that were too complex to be handled by the existing system. This presented the opportunity to pull in patches that distributions applied to their own packages, making things more compatible, fixing bugs, that sort of thing. We've implemented proper support for package revisions as well. So no longer will a simple change to an externals package result in a whole new package. The existing package can be updated in place. So we've also implemented soft version freezes to most of our externals packages in order to facilitate the transition to distro-provided packages. So updating an externals package that has or is likely to eventually have a distro-provided equivalent requires sufficient justification. Packages such as JWT-CPP that are not likely to ever have a distro-provided equivalent are free from this restriction. This does come with its own set of problems, however. For example, our Clang externals package supports C++ coroutines, but we can't use them because of incompatibility between Clang 13 and libstandard C++. And our CMake externals package does not support the newer versions of Python used in some distributions. Here's some other things that happen. As I mentioned before, the S3 resource plugin has absorbed libs3. This was done because libs3 wasn't really being maintained, and it made more sense to just adopt the code we need into the S3 resource plugin itself than to continue maintaining our own separate libs3 package with our own changes. This required relicensing the S3 resource plugin. So now either the GNU Lesser General Public License version 3 or greater or GNU General Public License version 2 or greater can be used when distributing the plugin. The Python Religion plugin has, the build for that has been properly parallelized. So now if you build with multiple jobs, you won't be stuck waiting for a single source file to compile. It's been properly split up. The development environment Docker files use new Docker file syntax. And if you're curious about that, you can see our development environment repository on GitHub. Development environment core builder can now use Ccache, which makes builds much faster for incremental development. And we now leverage CMake object library targets to improve our build system in a number of ways, very useful for a project of our size and complexity. So here's some notable next steps, some yaks in need of shaving. Non-package installation needs some work. Make install should be enough. Database plugins should be installable side by side. and our JSON schema IDs, which are currently absolute paths to their location on disk, should be URIs. We also need to look at file and directory ownership and location. Right now, we're shoving everything into Virlib iRODS, and everything is owned by the iRODS service account. We need to put things where they belong and only set ownership for the things that need it. We also want to provide default configurations or something along those lines. We want our automated and development environment builds to use a non-root user in their containers. We want to improve our CMake target names and make them more normal and boring. And we want to remove all the externals plumbing from our CMake. With all of this work that is being done, we have some things to consider, such as how our development workflow is going to change and how are we going to document the new workflows. How will our automated builds need to change? When are cleanroom builds warranted and how will we support them? And cleanroom builds are builds that start with an environment that is basically a default installation of the target distribution. And these are done to ensure that the packaging properly declares all of its build and runtime dependencies and that sort of thing. Continuing, how will we verify our dependency minimum versions and how often should we do it? How much of the iRODS server stand-up and cleanup process currently handled by Python scripts should be migrated into iRODS proper, and how? How long should we maintain legacy CMake target aliases once we switch to the new target names? And how will all of this affect the upgrade process? Do you have any questions?
All right. All right. Questions? I see we have one here.
Thank you for the presentation. iRODS has always been in decline of supporting semantic versioning, due to the complexity with compatibilities between patch and minor releases. Is that, is this a sign that you will be supporting semantic versions from a certain point onwards?
It is certainly a move in that direction. I don't know if I want to commit to the specifics of when you're supposed to update specific version numbers, because the way that we maintain compatibility, we might not maintain ABI compatibility between minor releases. It just depends.
Meaning that could we rely that if there is a patch release, that it will still be fully compatible? So any software that we would write, you could depend on the minor release rather than the patch release?
Yeah, if we do decide to do patch releases on top of minor releases, yeah, I would say that generally unless something horrible happens, that there would still be compatibility between the patch releases.
Excellent, thank you.
We had a hand up over here. Over here on the left.
Hi there. I'm just wondering what version of iRODS we're likely to see all these lovely things. Is this 4.3.2, or is this 5 or?
So some of this stuff will make it into 4.3. Like as we continue to move to fine package for more and more of our externals, there's no real reason not to have that on the stable branches as well as the main branch. But there are some things that as we continue to, like as the current main branch becomes the next stable and so on and so forth, there will be things that don't make it into stable, such as, for example, the libc++ to libstandard C++ change. That's only happening with 5.0. And I can't say for sure that everything that I have gone over in my presentation here is going to make it into 5.0, but I'm going to get as much of it in there as I can.
Thank you.
Any other questions? All right. Thank you, Marcus.